Welcome back. So we shall be examining empirical and molecular formula. So now when you're talking of empirical formula, it is the simplest formula of a compound which gives the whole number ratio of the component elements. So it doesn't give the exact number of atoms of element present in a chemical in a compound. So now, but when you're talking of molecular formula, so it gives the exact number of moles of atoms of the component elements in a compound. So let me use some illustration to differentiate between empirical and molecular formula. So now look at the popular glucose, for example, 66812O6. So now this is the molecular formula. This is the molecular formula of it. So now when, for example, now if we divide through by any number that comes, let's divide through by 6. What we have finally is CH2O. If we divide through by 6. Now this CH2O we have is our empirical formula. This empirical formula. While this is our molecular formula. So now if we take this, since we divide through by 6, that means n equals to 6. Are you getting it? So we can say M molecular formula equals CH2O CH2ON. Are you getting it? So when n equals to 6, if we multiply it through by, open the bracket by 6, what we have back is this. So that's the relationship between empirical and molecular formula. So we'll solve this problem together for you to get some application of what empirical and molecular formula is. Now look at the question. The question says carving the main simulant in coffee was analyzed via combustion analysis. The analysis shows that carbene consists of 49.48% by weight of carbon, this C, 5.19% of hydrogen, that's H here, and 28.5% of N, and 16.48% of O. Then I say, what is the simplest formula to the nearest whole number? Question mark. Then if the molecule of carbene is diatomic, what is the weight in grams of one molecule of carbene? So we'll solve this problem together. So now this is the first step. Okay, there is a formula used in this type of question, that's reacting mass over molar mass, or percentage mass over relative atomic mass. So that's the formula to use. So now the first thing you do, write represent each element present. B is carbon, hydrogen, nitrogen, and oxygen. Put them here. So now the next thing to do is percentage mass for each. So for this, that's 49.48, 5.19, 28.5, and 16.48. So the next thing is mole ratio. And don't forget that mole ratio is percentage mass over relative atomic mass. So now that's 49.48. Now relative atomic mass of carbon, that's 12. Then hydrogen, that's 5.19 over 1. That's then 28.5 over 14, and 16.48 over 16. So when you do it that way, then your mole ratio will be that will be 4.12 for here, for this 5.19, 2.06, and finally 1.03. So now the next thing you do, look at the smallest mole ratio there and use it to divide through. Now divide through by smallest mole ratio. So when you do that, what you have is 4.12 over 1.03, 5.19 over 1.03, then 2.06 over 1.03, then 1.03 over 1.03. So when you divide all through, you will discover that this one is approximately 4, while this is approximately 5, and this is approximately 2, while this one will be exactly 1. So can you see? So now don't forget carbon has this 4, hydrogen has this 5, so and so on. So the empirical formula will be C4H5N2O. So that's what the empirical formula will be. So so you've got the empirical formula. So they said what is the simplest formula? So they're actually talking of empirical formula. So that's that. So now the next thing, they now said if the molecule of carbon is diatomic. Now the diatomic means that N equals to 2, just like in the example of glucose I gave you. So that means you can use it to find the molecular formula. So molecular formula of caffeine equals C4H5N2O and 2. So equals C8H10N4O2. So this is the molecular formula of caffeine. So we can now go ahead with this. They now said if the molecular formula of caffeine, or if the molecule of caffeine is that, what is the weight in grams of one molecule of caffeine? So now, so what is the weight in gram of one molecule of caffeine? So what you do is this. What is the relative molecular mass of caffeine? RMM. So it will give you, when you find it out, so you can check our previous videos for that. So you get 194 gram, I guess. If I get, yes, you get 194 gram. So now when you get from 194 grams, so the next thing, just like we did in more calculations on involving moles and atoms. So they now say what is the mass. So now the next thing is do it this way. 6 times 10 raised to power 23 molecule is equivalent to relative molecular mass of carbon. So that's 194 gram. 194 gram. So what is the mass of, okay, so one molecule. So one molecule is equivalent to X gram. Are you getting it? So the same way we have been doing, you cross multiply. So when you cross multiply, so what you get is 3.22 times 10 raised to power 20 minus 22 gram. Are you getting it? So this is what this is what will be the weight in grams of one molecule of caffeine. So thanks for watching. So you can go through pause the video to see the steps of the calculation. Don't forget to subscribe and share. Thank you.